Hello. Hello, Shyam Sundar. Am I audible? Hello. Shyam Sundar. Am I audible to you? Hello.
Hello.
Yes, am
Yes,
I
am I
audible to
audible
you?
to you?
Yes, sir, you're audible.
Okay.
Okay, okay.
So
So
shall we
shall we
start the
start the
class?
class?
Yes, sir, you can start.
So
So
hello
hello
everyone.
everyone.
My name
My
is
name is
Sunny Kumar
Sunny Kumar
Sharma,
Sharma,
and this
and this
discussion
discussion
session is a
session is a
part of my
part of my
PMRF
PMRF
TA
TA
duty.
duty.
Today we
Today
will
we will
discuss
discuss
week
week
5 of
5
the
of the
course
course
Division of
Division of
Farm
Farm
Machinery,
Machinery,
which is
which is
taught
taught
by
by
Professor
Professor
Hifzur
Hifzur
Rahman.
Rahman.
And in
And
this
in this
session, we
session, we
will
will
solve
solve all the problems,
all the
all the
10
10
problems
problems
of
of
this
this
week.
week.
So
So
we will
we will
start
start
with
with
design
design
of an
of an
active
active
passive
passive
combination
combination
tillage
tillage
implement,
implement,
the
the
example of
example of
which is
which is
combined
combined
offset
offset
disc
disc
harrow.
harrow.
So in
So in
case of
case of
passive
passive
tillage
tillage
implement,
implement,
the
the
drawbar
drawbar
power is
power is
used for
used for
carrying out
carrying out
tillage.
tillage.
Drawbar
Drawbar
power is
power
used
is
for
used for
carrying
carrying
is
is
used for
used for
carrying out
carrying out
tillage.
tillage.
Like
Like
in
in
last
last
classes, we
classes,
have
we have
discussed that
discussed that
what
what
is
is
active and
active and
what is
what is
passive
passive
tillage
tillage
implement and
implement and
what
what
is
is
active
active
passive
passive
combination
combination
tillage
tillage
implement.
implement.
So in
So in
passive
passive
tillage
tillage
implement,
implement,
only
only
drawbar
drawbar
power is
power
used
is
for
used for
carrying out
carrying out
tillage.
tillage.
While in
While
case
in
of
case of
combination
combination
tillage,
tillage,
both
both
PTO
PTO
power and
power and
drawbar
drawbar
power
power
will be
will be
used
used
for
for
of the
of the
tractor will
tractor
be
will be
used.
used.
So
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 this
this
drawbar
drawbar
power
power
and
and
this
this
PTO
PTO
power
power
can be can
can
be
be
combined
combined
in
in
terms
terms
of
of
equivalent
equivalent
PTO
PTO
power.
power.
Like
Like both
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 term
term
which you are
which you are
seeing on
seeing
the
on the
screen.
screen,
This
this
term
term
will
will
be
be this term will be
used for
used for
drawbar,
drawbar,
and
and
this
this
term
term
2
2
pi
pi
nt by
nt by
60
60 for
is
is
for
for
rotating
rotating
that
that
disk
disk
arrow.
harrow.
So
So
both
both
this is
this is
from
from
PTO
PTO
power.
power.
So
So
this
this
PTO
PTO
power
power
and this
and this
drawbar
drawbar
power
power
both
both
can
can
be
be
combined
combined
and
and
can be
can be
expressed
expressed
as an
as an
equivalent
equivalent
PTO
PTO
power.
power.
So
So
PTO
PTO
power
power
available
available
PTO
PTO
power
power
equivalent
equivalent
to
to
the
the
drawbar
drawbar
power
power,
which is
which is
denoted by
denoted by
PE1.
PE1.
This
This
term will
term
be
will be
denoted
denoted can be
as
denoted as
PE1,
PE1,
and this
and
term
this term
can be
can be
denoted as
denoted as
PE2.
PE2.
So
So
whole whole
whole
power,
power,
that is
that is
total
total
P
P
total
total
PE
PE
power
power
can be
can be
denoted
denoted
as
as
sum of
sum of
PE1
PE1
plus
plus
PE2.
PE2.
This will
This will
become
become
more
more
clear
clear
when we
when we
will
will
solve
solve
when we will design
design
one
one
offset
offset
disk
disk
arrow,
harrow,
that is
that is
combined
combined
offset
offset
disk
disk
arrow.
harrow.
Means
Means
its
its
front
front
gang will
gang
be
will be
powered
powered
and
and
rear
rear
gang
gang
will
will
be
be
unpowered.
unpowered.
Means
Means
front gang
gang
will
will
be
be
active,
active,
which
which
will
will
be
be
getting
getting
power
power
from
from
PTO,
PTO,
and
and
rear
rear
gang
gang
will be
will be
unpowered,
unpowered,
which you
which
can
you can
see
see
here in
here
this
in this
figure.
figure.
Here the
Here the
front
front
gang
gang
is
is
getting
getting
power
power
from
from
PTO.
PTO.
Here the
Here the
front gang
front
is
gang is
getting
getting
power
power
from
from
PTO.
PTO.
PTO
PTO
is
is
giving
giving
power
power
to
to
this
this
gearbox,
gearbox,
and
and
from
from
there
there
power is
power is
being
being
transmitted
transmitted
from
from
this
this
shaft
shaft
to
to
this
this
disk
disk
harrow.
harrow.
So
So
this is
this is
powered or
powered or
active
active
tillage
tillage
implement,
implement,
and this
and
will
this will
become
become
passive
passive
tillage
tillage
implement.
implement.
So we
So
will
we will
first
first
design
design
this,
this,
and then
and
we
then
will
we will
solve the
solve the
numericals
numericals
or
or
the
the
questions.
questions.
So
So
before
before
proceeding
proceeding
further,
further,
so
so
if you have
if you
any
have any
doubt from
doubt from
last
last
week
week
1, 2,
1,
3,
2, 3,
4,
4,
which we
which
have
we have
already
already
discussed, you
discussed,
can
you can
ask,
ask,
then we
then
can
we will
proceed
proceed
further.
further.
Have you
Have you
solved those
solved those
questions?
questions?
Week 1
Week
to
1 to
4, have you
4, have you
solved?
solved? Sam
Sundar?
Sundar?
Yes, sir. Week 4, I have already submitted my assignment.
Week
Week
4 you
4,
have
you have
already
already
submitted.
submitted.
Yes.
Do you
Do
have
you
any
have any
doubts?
doubts?
Do you
Do
have
you
any
have any
doubts
doubts
from the
from the
questions, or
questions,
do
or
you
do
have
you have
any
any
doubts
doubts
from
from from the session, from those lectures?
A-
Like,
As of now, it is okay, sir. If I get some doubt, like in upcoming lectures, I'll be posting or asking you.
okay, like you can ask doubts related to the lectures also. Till you have solved till week 4, means 20 lectures you have already covered. So till
Uh,
20 lectures, you have if you have any doubts, you can ask here.
yes, sir. Actually, mostly I'm following your lectures only, sir. Like your problem solving sessions only.
Okay.
So with that, I'm able to clearly answer my assignments.
So
And
how you are following this session? Like you, I think you are first time here.
yeah, yeah, first.
So how you are following this session?
So previous sessions, I was watching the recorded lecture, and this is the first session I'm joining in live.
Okay, recorded. Where is that lecture available? Is that lectures coming to you by mail?
Yes, sir. Like I have all, as I already enrolled for this course. Like once you complete this session, it is visible. It is visible to me in that YouTube link.
Okay, understood. So actually, that quality was not good that I saw those videos. Like
Yes, sir. The
echo is
quality.
coming. Hmm. No, I saw
But okay,
the.
sir. Like your way of solving the problems is really helpful to us. So, I mean, if there is some technical subject, I think this disturbances language is not a problem. So, okay, there was an issue with that echo kind of thing, but it is fine, sir. It is manageable.
But from now onwards, it will not be there. I have solved that issue. That was due
Okay.
to means in recording session. It was like laptop's internal voice was also getting recorded. That I saw today only.
Yes, sir.
Hmm.
Actually, sir, I want to tell you, I want to acknowledge you. Last semester, also I have last semester, before last semester, I don't remember. Traction engineering course I have
Yes,
taken,
yes, yes.
and that time also I have followed only your lectures, sir. Like
Okay.
I couldn't able to come online, but that recorded lectures I have followed, and I was topper for that course,
Oh, you are
traction
topper.
engineering. Yes, sir.
Wow, great. Thank you. Okay.
And
Top these
actually,
exams.
like I personally acknowledged you by thanking the same. I think you might be busy, not seeing like
Oh, did you text me?
I have mailed you, sir.
Oh, I might not have
Email.
seen. It's okay. Thank you.
Okay, okay.
Okay. So you are
And
doing tech.
actually, intentionally. So this actually like every week I'm trying to interact with you in live, but I couldn't able to do that. But this week somehow I made it.
It's okay, no problem. It's okay. Look, then try to give best to this exam also. It will be
Okay,
good for
okay.
me. Okay.
Actually, sir, unfortunately, what happened, like I enrolled for this course, but unfortunately, I missed the date for that registration. But
Okay.
because of the passion, I am still following the lecture, solving the assignments, and submitting. Maybe next time I'll do my level best, sir.
Like you are already registered now.
No, no, I just enrolled, sir.
Oh,
So
okay, okay.
16th, they have extended the date, right? Exactly on the date when I checked, the extension is only for a few courses, not design of farm machinery was not listed.
Okay, okay,
So I
understood.
was busy with my office work, but still I'll be following your lectures, sir. It is very useful.
You should
And
have mailed me. I would have done something.
okay,
That you
okay.
have
It's
missed
okay,
your
sir. No, not
registration.
an
Okay.
issue. Maybe
Mhm.
actually NPTEL is giving a facility like if we submit assignments for a semester and if you are not able to write exam, the same thing assignment marks will be carried forwarded and directly we can appear for exam next time when this course is offered.
Oh, nice, nice.
Hmm. Actually, I already have domain certifications in artificial intelligence, data science, then programming, and twice I was awarded as discipline star in computer science, and
Great.
so like all the I mean from last 3 semesters I was actually I belong to South India, so Andhra Pradesh. So
Hmm.
last 3 semesters I was attending that NPTEL star felicitation function.
Great. So you have already done your BTech, I think.
Actually, I have completed my PhD, sir.
Oh,
Oh,
so what is
what
your
is your
education
from
from
where
where
it
it
is?
is,
Like
like BTech
BTech
and
and
MTech?
MTech.
Actually, MTech is like farm machinery from Andhra Pradesh itself, sir, like Vignan's University,
Oh,
Oh,
and
and
bachelor's?
a
bachelor's?
private bachelor's also from same university, sir, mechatronics
Hmm.
engineering,
Oh,
Oh,
nice.
nice.
PhD
and
PhD
from?
from?
actually completely interdisciplinary, sir, and PhD
Mm.
Hmm.
from NIT Rourkela, sir, industrial design,
Oh,
Oh,
great. So
great. So
what you are
what you are
doing
and
doing
now?
now?
You are
You are
and
in
you are in
industry, I
industry, I
think.
think.
no, sir. Right now, I'm working in Professor Jayasankar Telangana Agriculture University.
Mm.
Hmm.
For I mean, there is a project here based on digital agriculture. So in that
Oh,
Hmm.
project, I'm working as an AI and IoT expert.
great.
Great.
Mhm.
Okay,
Okay.
be in
Be in
touch.
Actually,
touch.
in
Hmm.
2019, I came to IIT Kharagpur for agri-food engineering for giving my PhD interview, but unfortunately, I was not able to crack
Oh,
it.
Oh,
no
So
no
that
issue.
time, I
issue.
have
Hmm.
seen that discovery. I mean, all this combination tillage equipment. There is a very interesting equipment called microcontroller-based
Ah,
weed
Ah,
removal system, right?
ah.
So
ah.
I have explored all those facilities, sir.
Oh,
Oh,
great. If
great.
you
If you
get
get
time
time
or
or
if you
if
get
you
any
get any
chance,
chance,
then
then
come here
come here
again.
again.
It will be
It will be
great
great
meeting you.
meeting you.
Definitely, sir.
Uh,
Definitely, sir.
Okay, then
okay,
we
then we
will
will
proceed with the
proceed with the
lecture.
lecture.
Okay, okay.
Okay,
Okay,
for
for
designing
designing
this
this
disc
disc
arrow,
arrow,
like
like
front gang
front
is
gang is
powered
powered
and rear
and
gang
rear
is
gang is
unpowered.
unpowered.
So
So
and
and
there are
there are
six number
six
of
number of
discs. So
discs.
if
So
you have
if you have
followed the
followed the
lecture,
lecture,
we have
we have
already
already
discussed
discussed
that
that
disc
disc
diameter is
diameter is
given by
given by
formula
formula
Ka
Ka
by
by
cos
cos
beta,
beta,
which is
which is
given
given
by
by
which
which
was
was
given by
given by
Bernanke
Bernanke
in
in
1970, I
1970, I
think.
think.
So
So
cos
cos
beta, where
beta, where
beta is
beta
the
is the
tilt
tilt
angle. In
angle.
case
In
of
case of
disc
disc
arrow,
arrow,
tilt
tilt
angle
angle
is
is
zero.
zero.
So
So
only
only
K
K
into A
into
will
A
be
will be
there,
there,
and
and
K
K
is
is
3 to
3 to
6, and we
6, and we
generally
generally
take K
take
as
K as
4.
4.
So
So
4
4
into
into
that
that
depth of
depth of
operation is
operation
12
is 12
centimeters.
centimeter.
So
So
48
48
centimeter
centimeter
will be
will be
diameter of
diameter of
disc.
disc.
If K
If
is
K is
5, then
5, then
60.
60.
So
So
we will
we will
take the
take the
diameter as
diameter as
51
51
centimeter,
centimeter
because in
because in
market
market
the
the
availability
availability
of
of
discs
discs
diameter will
diameter
be
will be
41,
41,
51,
51,
61, like
61
that.
like that.
So
So
51 will
51
be
will be
taken
taken
here.
here.
And now
And now
spacing we
spacing
have
we have
already
already
seen the
seen the
formula
formula
that the
that the
spacing is
spacing is
given by
given by
2
2
into root
into root
under
under
C
C
into
into
D
D
minus
minus
C,
C,
or
or
2
2
into
into
root
root
under
under
A
A
into D
into D
minus A,
minus A,
where
where
C is
C is
generally
generally
reach
reach
height
height
and A
and
is
A is
depth of
depth of
operation.
operation.
So
So
when
when
we
we
generally
generally
take reach
take reach
height and
height
depth
and
of
depth of
operation
operation
same,
same,
so
so
to
to
this
this
putting
putting
all those
all those
values
values
here,
here,
it will
it will
become
become
spacing will
spacing will
become
become
16
16
centimeter.
centimeter.
So
So
cutting
cutting
width.
width.
Now here
Now here
cutting
cutting
width, we
width,
have
we have
seen
seen
in
in
last
last
class
class
that
that
last to last class there are
there are
three
three
formulas
formulas
for
for
cutting
cutting
width.
width.
One is
One
for
is for
offset
offset
disc
disc
arrow,
arrow,
one is
one
for
is for
single
single
acting
acting
disc arrow,
disc
and
arrow,
one
and
is
one
for
is for
double
double
acting.
acting.
Double
So
acting
So
this.
yes,
yes, yes,
sir.
correct.
So
So
for
for
all
all
this
this,
there are
there are
survey
survey
equations for
equations for
cutting
cutting
for
for
having the
having the
cutting
cutting
width.
width.
So
So
using that
using that
offset
offset
disk arrow
disc arrow
formula,
formula,
we will
we will
put
put
all
all
this
this
N
N
and D
and D
here,
here,
and we
and
will
we will
get
get
width as
width at
0.91
0.91
meter.
meter.
So
So
this is the
this is the
cutting
cutting
width.
width.
Length of
Length of
shaft will
shaft
be
will be
calculated
calculated
not
not
from
from
width
width
but from
but from
spacing.
spacing.
Like
Like
spacing, we
spacing,
have
we have
something
something
S.
S.
So
So
spacing
spacing
into
into
number
number
of
of
disc is
disc is
6.
6.
So
So
6 into
6 into
number
number
6
6
into
into
spacing will
spacing will
be
be
96
96
centimeters. So
centimeters. So
this is
this
the
is the
length of
length of
shaft,
shaft,
and
and
width will
width
be
will be
this.
this.
Width of
Width
cut
of
will
cut
be
will be
this.
this.
This is
This is
width of
width
cut,
of cut,
and
and
this is
this is
length.
length.
So
So
moving
moving
further,
further,
now
now
when we
when
have
we have
powered this
powered this
gang,
gang,
as
as
this
this
powered disc
powered disc
gang
gang
is
is
has been
has been
developed
developed
here
here
only,
only.
like in
Like in
IIT
IIT
Kharagpur
Kharagpur
only, this
only, this
powered disc
powered
gang
disc
has
gang
been
has been
developed.
developed.
So
So
there was
there
no
was no
such
such
specific
specific
draft
draft
formula.
formula.
Like for
Like for
if that
if
is
that is
unpowered,
unpowered,
we have
we have
a
a
survey
survey
equation for
equation for
deriving the
deriving the deriving the
draft
draft
equation. But
equation.
for
But for
this
this
powered
powered
disc
disc
gang,
gang, this
this active
active
passive
passive
offset
offset
disc
disc
arrow
arrow
has been
has been
developed
developed
here
here
only.
only.
So
So
this
this
formula
formula
is
is
developed
developed
here
here
by
by
Upadhyay in
Upadhyay in
2020.
2020. our senior is there. So he has developed this equation for a specific draft, and this is the empirical equation for calculating the draft equation. So if we will put all those values of this coefficient C0, C0 to C5, and alpha and Ci values, we will put this here, then we will get a specific draft for a specific draft value as 11.77 kilonewton per meter square. So this is the specific draft which we will get from that empirical equation. So a draft of front gang will come as a specific draft into cross section area of disturbed soil. So cross section area will be width, which we calculated from Asave equation, width by depth of operation, that is D or A. So this will be the cross section area and this is the specific draft. So we will multiply that and it will come as 1292 Newton. So this is the draft of front gang, and we have discussed in last class that we have for disc harrow or disc plow, we have some empirical values for L by V, S by V. Every these fractions have some values which the table which I presented in last class also. So L by VT is 1.1 for disc harrow. So L is nothing but draft. So L by vertical force V is 1.1. So this value we have calculated as 1292. So 1292 by 1.1, when we will do, we will get vertical force, vertical soil reaction. So 1175 Newton. This is the vertical force V acting on the disc harrow. So this is trying to lift the disc for lift upward. We have discussed in first class that in moldwood plow, vertical force acts downward, and this in disc harrow, this vertical force acts upward. So this vertical force is acting on the 6 discs. So divided by 6, we will get 196 Newton. So this amount of force is acting vertically. Now offset disc harrow, this is the weight per meter of cutting width, like 390 to 650. Like if we will take 550 gram per meter of cutting width, then cutting width is 0.914. So this will come as 4,931 Newton. So this weight is this will be kg, not gram. So this weight 4,931 Newton is great, should always be greater, like weight of this weight of the implement should be greater than the vertical force. Then only this will penetrate into the soil and this will do the tillage operation. So here we can see that W is greater than VT. So this condition is necessary for penetration of the disc into the soil. Now length of the shaft we have already calculated, 6 into 0.16, that is 96 centimeter or 0.96 meter. Now how to design the shaft? This many times we have discussed that for designing the shaft we need to know what is the bending force acting on the shaft, what is the torsion moment acting on the shaft. So for knowing the design of for knowing the bending moment, we need to know that what is the normal reaction force acting on this shaft, that is denoted by RA and RB. Now there are two RA, like RA and RB is generally same. So RA equal to RB will be equal to WG minus VT by 2. This you can see from here that RA plus RB, this 2 is acting in same direction, that is upward, will be equal to this WG acting downward plus minus or this RA plus RB, and this 6V, 1 2 3 4 5 6V is acting in same direction, will be equal to WG. So this RA and RB will be WG minus VT by 6, WG minus VT by 2, and this WG is the weight of whole this offset disc harrow. So this will be divided by 2 for front gang, for front disc harrow. So this will come as 644.87 Newton. Now the shaft is subjected to bend. This is now what will be the bending moment. So this was just normal reaction force. The bending moment will be RA into this moment arm this distance,
then
then
v
v
into
into
this
this
distance,
distance,
then
then
this
this
v
v
into
into
this
this
distance,
distance,
and
and
this
this
v
v
into
into
this
this
distance.
distance.
So
So
for
for
this
this
line,
line,
for
for
this
this
cross
cross
section,
section,
but
but
the
the
bending
bending
moment will
moment
be
will be
ra
ra
into
into
this,
this,
then v
then
into
v into
this,
this,
then
then
this v
this
into
v into
this,
this,
this v
this
into
v
this,
into
and
this,
this
and this
wg by
wg by
2
2
into
into
this
this
distance.
distance.
So
So
when we
when
will
we will
compute
compute
that
that
thing,
thing,
ra
ra
into
into
3s,
3s,
1s,
1s,
2s,
2s,
and
and
3 3s,
3s,
ra
ra
will be
will
s
be
by
s by
2
2
plus
plus
ra
ra
is
is
acting at
acting
a
at a
distance
distance
of
of
s by
s by
2
2
plus
plus
s
s
plus
plus
s
s
plus s
plus
by
s
2.
by
So
2. So
this will
this will
become
become
3s.
3s.
Is the
In the
same way,
same way,
v
we
will
will
be
be
acting at
acting at
4.5
4.5
s
s
distance,
distance,
and
and
wg
wg
by
by
2 will
2
be
will be
acting at
acting at
1.5
1.5
s.
s.
So
So we
we
know
know we
we
have
have
calculated
calculated
ra
ra
value,
value,
we have
we have
calculated this
calculated
v
this v
value,
value,
wg
wg
value we
value we
know,
know,
and the
and the
spacing,
spacing,
what
what
spacing, what is the spacing,
spacing
that we
that we
also know.
also know.
So
So
this will
this
be
will
the
be the
bending
bending
moment
moment
acting
acting
on
on
this
this
shaft.
shaft.
So
So
this is
this
the
is the
bending
bending
moment
moment
value, and
value,
for
and for
torsion
torsion
moment,
moment,
in
in
this
this
formula we
formula
have
we have
seen that
seen that
how
how
this
this
di by
di by
cos
cos
alpha is
alpha is
coming.
coming.
Alpha is
Alpha
the
is the
gang
gang
angle.
angle.
So
So
this is
this is
number of
number of
discs,
discs,
and
and
this
this
force is
force is
acting at a
acting at a
moment
moment
arm
arm
of
of
not
not
exactly at the
exactly at the
radius.
radius.
Suppose
Suppose
this is the
this is the
disc.
disc.
So
So
and
and
this is
this is
the
the
torsion
torsion
moment
moment
which is
which is
acting.
acting.
This is the
This is the
draft which
draft
is
which is
acting.
acting.
This
This
draft is
draft is
not
not
acting
acting
at
at
exactly at the
exactly at the
radius,
radius,
but
but
r
r
minus a
minus
by
a by
3.
3.
At this
At this
distance, this
distance, this
force is
force is
acting.
acting.
So
So
torsion
torsion
moment will
moment will
be
be
this
this
force
force
into
into
this
this
moment
moment
arm.
arm.
So
So
when we
when
will
we will
compute
compute
that,
that,
it will
it
come
will
as
come as
295.61
295.61
Newton
Newton
meter.
meter.
Now,
Now,
for
for
we will
we will
take
take
the
the
shaft as
shaft as
solid
solid
shaft,
shaft, square
solid
solid
shaft,
shaft,
and for
and for
that we have
that we have
discussed that
discussed that
bending
bending
moment
moment
comes
comes
is
is
formula
formula
is
is
my
my
by
by
I,
I,
and
and
torsion
torsion
of the
of the
shaft,
shaft,
torsion
torsion
stress is
stress is
given by
given by
Tr
Tr
by
by
J,
J,
where
where
I
I
is
is
the
the
moment of
moment of
inertia,
inertia,
area
area
moment of
moment of
inertia,
inertia,
and J
and
is the
J is the
polar
polar
moment of
moment of
inertia.
inertia.
So
So
by
by
putting all
putting
those
all those
values
values
which we
which
have
we have
discussed
discussed
too many
too many
times, that
times, that
we will
we will
put all
put
those
all those
values
values
here,
here,
and
and
when we
when
have
we have
both
both
sigma
sigma
and
and
tau,
tau,
like
like
when we
when
have
we have
both
both
bending
bending
moment and
moment and
torsion
torsion
moment
moment
acting on
acting on
anything,
anything,
we
we
will
will
compute
we
the
compute the
torsion,
torsion,
we
we
compute the
compute the
design
design
stress
stress
tau
tau
max
max
by
by
1 by
1 by
2
2
root
root
under
under
sigma
sigma
square
square
plus
plus
4
4
tau
tau
square.
square.
This
This
thing we
thing
will
we will
put
put
here,
here,
and
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 when we
when
will
we will
put that
put
thing
that thing
here,
here,
it
it
will
will
it will
it will
come,
come,
everything will
everything will
come
come
in
in
terms
terms
of
of
b
b
only.
only.
Like for
Like
solid square,
for solid square
section,
section,
if
if
side
side
we
we
take as
take as
b,
b,
then
then
everything will
everything will
come in
come in
terms of
terms of
b.
b.
So
So
b will
b
be
will be
equal to
equal to
3
3
by
by
this
this
thing.
thing.
So
So
tau
tau
max
max is
is the
the
design
design
stress,
stress,
which is
which is
150
150
megapascal
megapascal
for
for
mild
mild
steel,
steel,
and
and
some
some
factor of
factor of
safety we
safety
will
we will
put.
put.
We
We
will
will
take
take
here
here
three
three
factor of
factor of
safety we are
safety we are
taking. So
taking. So
50
50
value we
value
will
we will
put.
put.
So
So
3 by
3 by
50 we
50
will
we will
take,
take,
and
and
ms and
ms and
ts we have
ts we have
already
already
calculated
calculated
in
in
previous
previous
slide.
slide.
So
So
from here
from
we
here
can
we
see
can see
that
that
b will
b will
come as
come as
3.108
3.108
centimeter.
centimeter.
This
This
is the
is the
design of
design of
shaft
shaft
for
for
front
front
gang.
gang.
In the
In the
same way,
same way,
design of
design of
rear
rear
gang will
gang
be
will be
done.
done.
And for
And for
that,
that,
we what
what
we
we
saw
saw
that
that
for
for
front
front
gang,
gang,
we
we
were
were
not
not
having
having
any
any
draft
draft
equation.
equation.
But for
But for
rear
rear
gang, we
gang,
have a
we have a
Sabi
Sabi
draft
draft
equation, which
equation,
is
which is
fi
Fi
plus
plus
fi
Fi
into a
into a
plus
plus
bb
BB
plus
plus
cb
CB
square
square
into
into
t,
T,
where
where
f is the
F is the
dimensionless
dimensionless
soil
soil
texture
texture
adjustment
adjustment
parameter,
parameter,
whose
whose
value
value
can be
can be
seen in
seen
the
in the
previous
previous
slides,
slides,
in
in
previous
previous
lectures.
lectures.
And
And
va and
VA
v va
VA
is the
is the
velocity,
velocity,
speed, or
speed of
speed of
speed of
harrowing
harrowing
operation,
operation,
and
and TD is the depth of harrowing. So every time we will take care of the dimension, we will take care of the units, and we can get the draft value. So we will put all those values here, and we will here it can we can see that the draft is coming as 3184 Newton per meter. So this is per meter, and total width we know. So we will multiply that meter into this Newton per meter, and we will get what is the draft. Again, we have L by VT as 1.2. From here, it will V value will come as 2425 Newton. So for rear gang, you can see the change. So this V is changing for rear gang, and we will divide by 6 for each disk, so which is 404.19 newton. So design of shaft will be done again. So again that same procedure will be followed. Here Ra, that is normal reaction force, is coming very less, that is 20.3 newton. Again this bending moment will be calculated. Everything will be similar. Here torsion moment will be calculated. Only this draft value will change, and in this equation, Ra value will change. Wg will remain similar. In this torsion value, Di will change. So accordingly, we are getting torsion moment as 665.85 newton. So here we can see that bending moment due to very less Ra value, we are getting very less bending moment. Again, the same procedure will be followed for calculating the dimension that of solid square shaft, that is B. And when we will put all those values of ms and ts, we will get the B value as 3.91 centimeter. This was the procedure for designing the shaft. For design of frame, for design of frame, again we will see the same thing, that we will see that whether bending or torsion moment is acting, or whether both is acting. So in the design of frame, bending will be due to vertical force on shaft, and torsion will be torsion due to draft. Same procedure will be followed, and we can see that this is the frame, and maximum bending moment. Again we can see that it is Ra is acting at a distance of s by 2 plus s plus s by 2, and Wg is acting at a distance of at a distance of Wg is acting at distance of 1.5 s. Here this is the frame, so we are not considering that any vertical force is acting, because vertical force was acting in case of this shaft. So in case of frame, for this frame only Wg is acting and Ra is acting. So these two force will be considered for bending. And for torsion moment, the same thing will be there. Torsion moment will be due to draft, and it will act at a distance of d minus, not r, here it is d, it is d minus a by 3 plus some clearance. This clearance is there. This clearance is there, and diameter plus this clearance, diameter plus this clearance plus minus a by 3, at this moment arm that draft will be acting. So torsion moment will be computed using this equation, and bending moment will be calculated using that this equation. Again same thing will be followed for solid square frame. Sigma will be my by I, and tau will be t r by j. And everything will be confined with an expression with having b only, and b will be b, when we will compute, it will come as 4.13 centimeter. For front gang, so draft value is different and Ra value is different. So for front gang, the shaft will be of dimension 4.13 centimeter, and for rear gang, the for the design dimension of the solid square shaft will be 5.44 centimeter. So summing up all the design parameters, we can see that design of dimension of the gang shaft for front gang is 3.108, for rear gang is 3.9 centimeter. This is for shaft, and for frame these are the dimensions. For front gang it is 4.13, for rear gang it is 5.44. So this was the design of shaft. For power requirement, as I was discussing in the first slide, that PTO power will be required for rotating the front gang. So PTO power required will be 2 pi n into t by 60. So for t, that is torsion, this will be computed using, t will be calculated by what is the force acting, and at what distance, like what is the moment arm of that force. So this torque is the draft force which is acting at a distance of this moment arm. So 2 pi 2 pi n is 180 rpm, and this value is the moment arm, and 60 and 0.9 is the transmission efficiency. So this is 6.19 kilowatt. This is the PTO power required for rotating the PTO power required for the front gang, and drawbar power required for overcoming the draft will be draft of front gang draft of front gang plus draft of rear gang into forward speed. So draft of front gang is we have already calculated earlier 2445 Newton, and draft of rear gang also we have calculated. So these two we will sum up, and forward speed will be multiplied. So drawbar power required will be 5.36 kilowatt. So 5.36 kilowatt is there, and drawbar power required for overcoming the motion resistance, that is the total weight of the implement and tractor. So weight of the tractor is 2200 kg and weight of the implement is this one. So which we have already calculated. So combining both, this is the total weight of tractor plus implement. So this force is 8% of that force we will take, and it will come as 2.12 kilowatt. So 2.12 kilowatt is the force required for moving motion for overcoming the motion resistance for both tractor and implement, and for overcoming the draft. This is the power requirement, means 5.36, means 2.12 plus 5.36 is the drawer power required for both overcoming draft and motion resistance. So this will come as 7.48. So this is the total drawer power required. And so we were discussing that what should be the equivalent PTO power. So equivalent PTO power is PE1 plus PE2. PE1 is the power required for first moving only for PTO power. So 7.48 was the PTO power. 7.48 by 0.86 is drawbar is PTO power to drawbar. So this you can see that transmission to drawbar, PTO to drawbar is 0.86 to 0.89. So 7.48 by 0.86 is equivalent PTO power to total drawbar power, and PTO power required to rotate the front gang will be 6.19, which we have seen above. 6.19 is the PTO power required for front gang. So 6.19 was just PTO power for front gang, and this is the equivalent PTO power converted to drawbar power converted to PTO power. So we will combine both 6.19 and 8.619. When we will sum both, we will get total PTO power required as 6.19 plus 8.619, 697. So this is 14.887. This value is the total PTO power, total equivalent PTO power value. So taking 20% power reserve and transmission efficiency is 87%, we will get the value as 20.53 kilowatt. So with this we will solve some questions. So the first question is of week 5 is the correct expression for computing disk spacing between two adjacent disks in a disk harrow is. So what should be the correct answer?
Option B, sir, I guess.
Yes, just now we have discussed that 2 into root under C into D minus C will be correct answer, because it is outside the root. Here only root C is under, here no root is there. So only so option B is correct. And next question is the total power equivalent PTO power PE required for carrying out delays with active passive combination delays implement is expressed as. This whole design we did just now, so we can solve
Yes,
this.
sir. Just before you have explained all this, but this is a bit confusing because of lot of parameters involved in that.
Yes, correct. So here DC it is total draft obtained by combination disk harrow. DC is the draft for combination disk harrow, and 2 pi nt is for rotating for p, 2 pi nt is the power required for rotating the harrow. So on here, what is not considered, rolling resistance of the tractor, overcoming the motion resistance of tractor and implement is not considered here. So this cannot be considered as equivalent power. Here in
Then
this
correct
case,
answer is D, sir.
yes, D will be the correct answer because here
Yeah,
everything is
because they have
considered.
considered rolling resistance and all other parameters.
Yes, yes. So D will be the correct
Longest
answer.
formula.
Yes, yes. So this is the third question. A combined offset disc harrow with four discs in each gang is operated by a two-wheel drive tractor in sandy clay loam soil. The front gang of the offset disc harrow has a gang angle of 25 degree and is powered by a tractor PTO and is rotated at 200 RPM. The PTO power available is 24 kilowatt and the PTO power equivalent to the total drawer power is 2.6 kilowatt. The torque available at the gang shaft of the front set of combination series implement with power transmission efficiency 0.95 in kilonewton meter is what they are asking, the total torque available at the gang shaft of front set, like for front set. So PTO power available is 24 kilowatt. So PTO power available, that is PE is given. Total PTO power is given 24 kilowatt. P is which is sum of PE1 plus PE2. PE1 is the power required for rotating the disc harrow and PE2 is the drawer power plus 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 power required to overcome the rolling resistance. So and the PTO power equivalent to total drawer power is 2.6 kilowatt. So this value is given as 2.6 kilowatt. And PE value there it is given 20 the PTO power available is 24 kilowatt. 24 kilowatt is available and for and equivalent to drawer power is 2.6 kilowatt. So only for rotating the disc will be PE1. So PE1 will be 24 minus 2.6 kilowatt. 21.4 kilowatt. So this is for just for rotating the disc harrow. So this is the for rotating the disc harrow means 2 pi nt value is this one, means 2 pi nt by 60. So 2 pi n is given, like RPM of the disc harrow is given 200 RPM.
Yes, sir. 200
Torque we
RPM.
need to find. This is RPM of front gang, torque of front gang by 60. So torque we can find here. So you can calculate and tell me that what answer is coming.
Just a second. 1022, sir. Maybe there may be some error in conversion, or it should be 1.02. 1.02, sir.
1.02 is coming.
Yes.
Wait, let me check.
Or there may be some error in that conversion factor kind of.
So have you taken this efficiency? Like 2 pi nt by efficiency value will be the 60 into
Okay. Yes.
efficiency of
Efficiency value has not taken.
transmission efficiency.
0.9. Okay. 0.97.
0.97. Yes, 0.97 is the correct answer. Hmm.
Actually, 1.02 I got because I didn't take that
Yes.
efficiency test.
Efficiency. Yes. Yes. That's why they have made the question. Like we have made the question like
Uh-huh.
this. Hmm.
Yes.
So this is a matching problem. So how actual speed this is the thing to be calculated to be computed, and this is the way of calculation. Like for actual speed, how do we calculate actual speed? Do you have idea that what thing will be used for calculating the actual speed from column B?
For soil pulverization, penetrometry is used.
For soil
And
pulverization, penetrometer will be this. Yes.
soil inversion, squaring is used.
Hmm.
And for actual speed, I think rear wheel and theoretical speed, front wheel are interchangeable.
Actual speed front wheel is used because a front
Okay.
front wheel is just towed. There is no slip and nothing, like it.
Oh,
It
yes,
will
sir.
just it is just moving forward. So actual speed we get from front wheel, and theoretical speed we get from rear wheel.
You get rear wheel. Okay.
Yes. So 1C 2B 1C 2B
2B, 3,
3 3D
3, 3D.
3D
Yeah, option B is
4A.
correct.
Yes,
Option B.
option B is correct. So this is Tilly's performance index topic. Like Tilly's performance index, how do we compute Tilly's performance index for all the implements? Till like Tilly's implement is going to be complete from this week. Week 5, week 6. From week 6, we are moving to uh, spraying. I think spraying, threshing, and all. So this is at last we are discussing how do we calculate the Tilly's performance index of any Tilly's implement. So for knowing Tilly's performance index, this Tilly's performance index is directly proportional to quantity of work done. If we denote it as Q1, quality of work done, that is QL, and it is inversely proportional to energy requirement. So more energy it is taking, less is its performance index. Less energy it is taking, then it is good. So this is directly proportional to Qn and QL and inversely proportional to E. Suppose for rotavator, what is the tillage performance index? So this will be directly proportional to Vs and delta Ci by Cib, and F is the fuel energy consumed. Vs is the volume of soil handled. This we have already discussed in last class about while discussing rotavator and combined disc harrow. That
Yes, sir.
how do we calculate these values? So Vs is volume of soil handled. Delta Ci by Cib. Delta Ci is the change in cone index, and Cib is the cone index before operation, before tillage operation. So this should be like this. So tillage performance index of rotavator or active tillage implement will be Vs into this thing. For combined disc harrow, it will the watch this will be again Vs into delta Ci by Cib into this soil inversion term will be there for disc harrow. For rotavator, it is pulverizing the soil. For disc harrow,
Sir,
it
can
is
you little zoom out the screen, sir? Because some of that zoom out, sir. Zoom out.
okay. Okay.
Yes, sir. Now it is perfect. Because that terminology, some of the terminologies are not visible from. Now it is fine.
It's okay. It's okay. So this for disc harrow, for disc harrow, tillage performance index will be directly proportional to volume of soil handled, delta Ci by Cib, and this soil inversion term will also be additionally coming. So performance index for moldboard plow, what it will be? This will be performance index will be depth of operation into effective field capacity, which is denoted by A, and this should be in hectare per day. So this will be D into A into soil inversion term will be there in both in case of disc harrow and moldboard, because they are inverting the
Moldboard
soil.
plow.
Yes.
Yes,
So they are inverting. So this inversion term, soil inversion will be there. And how do we compute this soil inversion? This also we have discussed. What is the number of weeds before plowing? What is the number of weeds after plowing?
with
Then that
after
too.
flying by before plowing.
Yeah,
With
before plowing.
before
So this will be computed in percentage, and that will be the
percentage.
soil inversion. So this into P is the pulverization, that is penetrometer reading, which give,
penetrometer.
yes, that gives the pulverization. So by D, that is du or D, that is a specific draft, is in kg per centimeter square. So in case of moldboard, this will be the tillage performance index. This will be the performance evaluation of moldboard. Performance evaluation, if someone tells to compute for disc harrow, so this will be the main criteria. For short run test of any implement, we need to have at least three series of field test for short run. And for long run test for harrow, the harrow should be operated for at least 50 hours, exclusive of the period covered under short run test. So if possible, it may run up to 200 hours. So at least 50 hours should be there, and max should be at least 200 hours we can go. The parameters to be measured in short run test is width and depth of cut, soil pulverization, power requirement, field efficiency, ease of operation and adjustment, soundness of the construction. Testing of the tillage implement. So testing of the disc harrow should be carried out at 5 selected fields previously plotted. So the area should not be less than 0.2 hectare for disc harrow mounted or trailed by a tractor and 0.1 hectare for others. So this is the test parameters and test conditions. So the test conditions have to be mentioned. The items should be measured. So these are the things to be measured while having the test. While having the test evaluation, so the parameters will be width of harrowing, actual travel speed, number of passes, actual operating hours, time spent for adjusting the implement, time spent for travels and others, fuel consumption. So these all times will come under actual field capacity. So fuel consumption, degree of pulverization, degree of mixing of vegetative matter, and evenness of the harrowed surface, percentage of wheel slip and draft. These these 10 12 parameters need to be considered while while doing the performance evaluation of the implement. So one question was also discussed there in this week, that we need to find out the performance index of a moldboard plow. So for moldboard plow, we just saw that the formula is DAI by P, DAI, DAI P by D.
P by T. D.
Yes, D. This is the tillage performance index of moldboard plow. So what they are asking, a 2 into 30 centimeter moldboard plow was operated in an untilled plot of size this. This is the plot size at an actual forward speed of 2.5 kilometer per hour. And the following observations were recorded. So these are the observations. So find out the performance index. So D will be depth of operation in centimeter. A will be the effective field. A is the effective field capacity in hectare per day. So effective field capacity will be, this area is covered in how much time? This area is being covered in 48 minutes. In 48 minutes, this area is being covered. So from there, we can directly get the actual field capacity. So actual field capacity in hectare per day will be this will be in meter square by this time. So that we can calculate. And I is what? Soil inversion. So we can see that mass of weeds before plowing is 40 and mass of weeds after plowing is 6. So from here we can get soil inversion, and P is the penetrometer reading. So penetrometer reading after plowing is 10 centimeter. So everything is given in draft. A specific draft we need to know. So a specific draft will be, here draft is given, and what is the cross section of the moldboard? 2 into 30
42.
centimeter.
2
Yes.
into 30.
So can you calculate this? You just give a try, because it is very means
Uh,
you.
no, actually, okay, sir, it is fine, but the problem is with the unit conversion. We have to
Uh,
remember all that unit conversion kind of.
like here it is given. See, suppose field effective field capacity is this 45 into 22, area is being covered in 48 minutes. So this will be
Uh,
this will be this much meter square per minute, and we
so
need
that one
to
we are converting into hectare per day. Yeah,
hectare per day, that
unit
will be
conversion part.
converted. So soil inversion will be mass of weeds before plowing, mass of weeds after
48
plowing.
minutes.
So this will come as 85%.
85%.
Soil pulverization reading, soil penetrometer reading is 10 centimeter, and the specific draft is draft which was 4.5 Newton, and this will be divided by cross section area of furrow. So this is the cross section of area of furrow. So this will be divided by 9.8, and this will come in kg per centimeter square. So what will be the performance index? So everything will should be in same unit, which is given in formula. So from there, performance index will come as this value. So we can move to the next question of the week 5. So fifth question is tillage performance index of any tillage implement is inversely proportional to.
Option A, sir. Energy requirement.
Yes, energy requirement. Just now we have discussed.
Just
So
we have discussed.
yes. So question 6 is mass of weeds before and after operation of tractor drawn moldboard is 40 gram and 5 gram. When it is operated at a depth of 15 centimeter. Soil pulverization in terms of penetrometer reading is 10 centimeter. Effective field capacity is 0.8 hectare per day. Performance index of mold plow. Everything is given in same unit what we need.
Yes, sir.
So this can be calculated easily. So what value is coming?
Just a second. Mm, Soil polarization. Um, So actually, for calculating the draft, can we take this depth into soil electrometer reading kind of thing?
This soil penetrometer reading will be this is P, I think, DAI into P. This is penetrometer reading, and
Okay.
DAI P by draft. So draft value is also given as 0.6 kg per centimeter square.
Per
This is
centimeter
specific.
square.
Mm.
That
This
is
is the
specific draft. DU, right, sir?
this is the DU only. This
Okay.
is DU.
DAIP by DU, right? So the small d value
DAIP by D.
by
Yes,
DU.
this
So
DU. Yes,
DU is the specific draft.
DU is the specific draft in kgf per centimeter square.
Hmm. 0.10 actual field capacity. So soil inversion value is 87.5.
Soil inversion is
87.5.
35 by
40.
40 into
40.
100. Yes.
Mm, T is 10. What about that small d value, sir?
Small d, which this one.
Ah,
This we can take. We will take directly this 0.6 kg per centimeter square.
that is specific draft.
Uh,
So top there
oh,
is a
this is
drop
the
value.
depth of operation
Okay.
in centimeter.
Okay. Okay. Sorry.
Depth of operation. This
Okay. Fine. All the values. On 3 into 87.5 into 10 into 15. I think somewhere I have made mistake. It is coming around 17,000 kind of thing.
what it is coming?
Just I'm recalculating it.
12 into 0.8 is the area effective area into this is 35 by 40 into 100. This is I into P is 10 by 0.6.
Okay, depth of sir, where is that value? How did you get that value 12?
This 12, sorry, this
15, right?
this is 15.
Yes, sir. 15 into zero point 0.8 into 87.5 into 10 by 0.
Yes.
15 into zero point 0.8 into 87.6 into 10 divided by zero point 0.6. Sir, it is coming 17,500, sir.
17,500.
500.
Okay, means this will be the correct answer. If you are getting that value, means this will be the correct answer. Means in
Maybe
options,
it is calculated based on 12. That depth you might have taken 12.
depth, yes, yes, depth on always I take 12. That's why.
Ah,
Mm.
yes, sir. Just
So
I
if,
will.
17,500 will be the correct answer according to this 15 centimeter. Now,
Yes, sir. If you are taking 12, it is coming around. It is coming 14,000.
oh, then
Okay.
then
Then option D is correct. If you take 12, depth as 12.
hmm,
If you take 15, it is coming around. It is coming like
okay.
17,500.
Okay, you can check like in this year we
Ah,
have
yes.
set this
When
question or not. Maybe this question is there. So accordingly, you can check the answer. If it is incorrect, like if
okay,
answer is mismatching, you can tell me.
okay, okay, sir.
So one
No
more
issue.
thing is there, that how do we calculate the draft of the implement? Like the 3 point linkage is there. So in sensing unit, we have uh, we have a strain gauge we have a strain gauge attached here in the this is top link and this is the two lower link. Everywhere we can get that what is the compression or tensile force acting with the help of this strain gauge. And in all these 3 point linkages, like one, this is first point, second point, and this is the third point. This is the third
Yes,
point.
yes, sir. Yes, sir.
So at all these points, while it is moving, it is calibrated in such a way that how much it has moved at what angle. So with the help of potentiometer, we can get that what is the angle it has moved with respect to horizontal plane. With respect to horizontal plane, what angle it is making. So that will be the angle associated with all the 3 point, and what is the force, compression or tensile force acting on all these three links, that we can also get with the help of the strain gauge or a kind of load cell. So if we are knowing that what is the tensile force in the lower link, that is TF, what is the bending force in the lower link, that is BF, and what is the compressive force in the top link, that is CF. Like CF top link will be in compression and lower link will be in tension. These two lower link, what is the force, tensile force acting, and what is the compression force CF in the top link. So that force we can get from with the help of a strain gauge reading, and what is the angle they are making, that we will get from potentiometer reading. So theta is the angle of lower link in the horizontal plane, and phi is the angle of lower link in the vertical plane, and gamma is the angle of top link in the vertical plane. Top link with respect to vertical plane. With respect to vertical plane, it is making some angle, that is gamma. And theta is the angle of lower link with respect to horizontal plane. And phi with respect to vertical plane for lower link. So all these three angles and all these three forces, if we are knowing, so this will be summation of two lower links. So this is not for one link, this is for two link. Like for two lower link, this will have two values. So this will be multiplied by this will be have two values, and this will be a single value. So from there we can compute that what will be the draft force acting. So if the force acting on the bottom and top link in the 3 point linkage, as well as angle associated, are are given by this nomenclature or notations. So what will be the draft of implement? So this, from that formula we can answer
Option
this
C, sir.
question.
Direct,
Option,
direct question. Option C.
mm, which option was there?
Option C, sir.
Okay, option C will be correct answer. So, which of the following is an additional factor to be considered for calculating tillage performance index for a combined disc harrow as compared to the rotavator? So, in rotavator, some tillage performance index is there, and in case of disc harrow, some tillage performance index is there, and some additional factor is coming in case of disc harrow. What is that additional factor to be considered, which is not there in
Soil
rotavator?
inversion, sir.
Yes,
Soil
just
inversion.
yes, this we have
In
discussed.
rotavator, we don't have soil inversion, whereas in
Yes, yes,
this kind of thing, we'll have that. Yes.
yes. So, which of the following statement is correct? In the short run test, at least three series of field tests for short runs should be carried out under different soil conditions. And second, the statement is in long run test, the harrow should be operated for at least 25 hours, excluding the period covered in short run test.
Option A is correct, sir. In long run test, I think 200 hours.
And in long run test, the harrow should be operated at for at least 50 hours. At least 50 hours, and maximum we can go 200 hours. So only
200 hours.
statement one is correct.
One is correct.
So last question for of the week 5 is soil pulverization is measured by. This is also simple and direct question.
Yes, sir. Option D, sir. Both sieve analysis and cone penetrometer.
Sieve analysis for soil pulverization, yes, that is correct. So we have solved all the questions of week week 5, and I don't think in solving week 5 questions of this year also you will get any problem. So if you get any problem or if you have any doubt, we can connect here in this live session on Monday from 6 to 8. So do you have any doubt in this class, Sam Sundar?
Yes, sir. Actually, maybe that actually my query is regarding the draft of the implement. Sir. Previously, you have told about that strain gauge measurement, right?
Yes.
So, no, I'm asking generally. So, for research purpose, we are going only for strain gauge, or we are going for other dynamometers like hydraulic, mechanical. We are having that also, right?
Yes, like two, three methods are there. Like
Hmm.
I have in week in 25th lecture, sir has discussed all the methods of calculating the draft for 3-point linkage. There are two general methods. Name I am forgetting. One is this method and one is dynamometer, which you are telling. So both method is there. So there we are developing some sensing units here. Like in our lab also, 3-point linkage draft sensing unit was developed.
Hmm.
So that model I can show in next class if you are willing to know. That developed sensor is there.
Yes, sir. Definitely, sir. Okay.
Okay, that I will
Definitely,
show
sir.
in
You
next.
can show. It is very interesting
It is there.
because electronics applications in farm
Okay.
machinery, that is really interesting. So that we
Hmm.
can
Yes, correct.
avoid a lot of frictional elements kind of thing, and it
Hmm.
is more accurate compared to lot of mechanical linkage.
Yes,
Only
actually,
thing is, like as
hmm.
you told that I could have mailed you, sir. I missed that course for this semester. Maybe in
You
the
should have
next
mailed
semester
me.
I can appear for this course.
I will try. Like for now, also I will try that if there is any possibility that you can enroll.
Okay, sir. Definitely, sir. It will be. I will be very fortunate if I get that registration link open. Immediately, I'll register for this course, sir.
Okay, I will try my best. And you take my number. You just ping me on
Okay.
WhatsApp. I'm
Or
writing
else,
it down.
yeah, should I mail in that form, sir? There is a query Q&A form, right? Should I mail in that form also so that it will be recorded?
No, you can. No, that I will try from my side. You just text me on my WhatsApp
Sir.
number, which I am sending here on in this chat box.
Okay, okay.
Did you receive?
Yes, sir. I have received. And sir, one more thing I want to ask you, like,
Yes.
so, like previously, and Actually, one thing I want to thank you, sir. Almost after 5 or 6 years,
Hmm.
I'm coming back to this farm machinery again because when I went back to PhD, so PhD topic was a bit different. So soil health analysis using sensors and artificial intelligence application. So I completely, to be frank, I completely left this farm machinery. And thank you very much for this course. So I'm able to recall all the fundamentals of farm machinery with the same interest I have joined in this. But fortunately, if you can, I mean, if everything works fine, I'll be able to register for this. Let us hope for the best. And the content is
Let's.
very good, sir.
Okay. Yes, it's our pleasure that you people are getting benefit from these courses. So
Yeah, definitely, sir.
yes.
Generally, what happens is like if you follow ICR, especially for this design of farm machinery. So if
Hmm.
you follow ICR courses like farm equipment one and two, or if you follow the design of a farm machinery by Sharma and all. I
Hmm.
mean, the content is okay, but there are many pain points in that course because
Yes, yes.
most of the
Everything
pain points
summed
will
up
be
you
there.
will get here only. Like every design
And
thing will.
especially, yeah, especially that testing of farm machinery, some of the important concepts also you are covering in that. Or
Yes.
else we have to take a separate course, the testing and evaluation of farm machinery. But the main
Correct.
important ones, how much of area is required, that you are covering very well in these courses. This is really very good, and I feel even for ICR net exam also, the design of farm machinery course will be very useful.
Hmm. Yes. Thank you very much that you are getting benefit. Okay, then we will be in
And
touch.
sir, one more thing I want to ask you, like generally in farm machinery while designing, we will be getting some value. Like previously, when you are designing that disc, I mean diameter of the disc, we got
Hmm.
some value, but you have taken some standard value that is available in the market.
Yes, yes.
So all these values were taken from that design data book, sir. Design data book
Yes,
or
design data book is there. Many reference books are there. Like in TPC also they have given this like data book. Yes, from data book we can get those values. I've also seen in many three four books. Like in TPC, I've seen that they are giving that what are the market available standard values.
yes, sir. Actually, because any farm machinery design problem, if you take even the DN Sharma book, also they are directly mentioning this is the value, but
Hmm.
there is no reference from where that value is taken.
Okay, have you
So
seen
there is no
the design data
citation
book?
for that. Yes, sir. I have seen. Sir.
Like these values are available there or not?
Yes, sir. Because I told you right very long back, I was saying I'm
Ah,
not able
okay.
to recall.
Okay, the
But
exact source if you want, then I will that also if you what are your doubts you can send me on WhatsApp. I will I will discuss those things in next class.
okay, definitely,
Okay.
sir. And so this, like, sir, actually we are calling this lower two links as tension link and upper link as compression link, right? In three
Yes,
point
yes.
each.
Hmm.
Sir, can you just tell me like how that is actually came to know how that is computed? Is there any experiment regarding that,
Like
or just by mathematical calculations or kind of that?
like this is suppose top link and this is these are two lower links. This is a whole tractor system design part. You have studied in farm machinery, like in your master's course you have might have studied.
Yes,
Like
yes,
this is top link.
yes,
This lower link is under
lower
like
link.
hmm, like when this it is carrying some implement, this lower link it is carrying some implement, and
Yeah.
when some obstacle is coming, like when while it is dealing, so what it is trying to do, this implement is trying to pull from lower side, it is trying to
Oh,
pull,
uh,
it is trying to pull the lower link. So from due to that thing, lower link is under tension, and when it is trying to pull that thing, one rotation is coming, and upper link is automatically coming under tension, coming under compression. So upper link will be under compression and two lower link will be under tension. That is a general like layman's perspective to see this thing. But whole but this
no,
whole
that I
hmm,
understand, sir. Like,
hmm.
is there some many experimental data or some? mathematical relation kind of thing.
Mathematical relations between what all things?
Mathematical relations
Relations among what all
relates
things you
to
want?
say exactly that if these two links are under tension, mathematical relation or any
Mathematical
experiment data
relation.
that shows that
No, it's
uh,
like it is designed in such a way that this two should be under tension and first link should be in compression. It is like from designer manufacturer side that this should be there. Like this is for small tractors. If when you will go for large tractors, then the thing becomes opposite. Like upper link is used for sensing the tension and to lower link becomes compression. So this is
yes sir,
with
actually
designer's
like
perspective.
I have studied it somewhere, that's what I'm asking.
Hmm. Yes, yes. You are asking that correct thing. It is a whole hydraulic
That's what
chapter,
I'm
not.
asking. I've studied
Hmm.
it somewhere, so that's what I'm confused. Okay,
Hmm.
okay.
Yes,
Now
your
it's clear,
confusion
sir.
is
Okay.
okay. Hmm.
And
Okay.
sir, one more thing is like, so if we go for mounted implement, semi-mounted implement, or completely the implement which is dependent, then how can we justify that exactly these two links are under tension and compression? I mean,
Yes,
soft
that
link is
should be
under.
mentioned. That should be mentioned in the question if
So what
they are.
your analysis is? Okay,
Hello.
okay. For
Hello.
like
Hmm.
fully mounted implement, that is fine. But
Hmm.
sir, can you hear me, sir?
Yes, now you are audible. Yes.
Fully mounted implement, that is fine, sir. When you are going to semi-mounted implement, for example, if you go for any other semi-mounted implement where there is an extra wheel for support, then there might be slight changes because we have many undulations in real-time agriculture field rather than what we assume, right? So,
Yes, yes.
okay. Now it
Correct.
is clear, sir. For larger tractors,
Hmm.
it is elaborate and okay.
Hmm. Okay then.
Okay, sir. Like, I'll just go through that current week assignment, week five
Ah.
assignment.
Ah.
If I
Sure.
get some doubts, I'll be noting down and
Okay. Okay.
next
Okay then. Shall we
next
end the
week when
class?
you're coming for this session. And if
Ah.
I'm available, just I'll try to
Ah.
address it.
Sure. Sure.
Okay, sir.
Okay.
Definitely.
Okay
Thank
then.
you, sir.
Okay. Thank you. Bye.